Okay, guys. There we go. Lesson 2.8. Two variable inequalities. So, graphing. I know your favorite topic, right? But it's not that bad, I promise. I know some of you have already seen graphing and you're like, oh, no, I can't do graphing. Yes, you can. You have to change that mindset, and you guys can definitely do graphing. And we're going to work on this. Now, when we say graphing with inequalities, what's the big difference about our graphing? We're going to graph our curve or line, and then what do we have to do to finish it off if it's an inequality, so less than or greater than? Yeah, we're going to have to do shading. So this is where you're either shading above or below the graphs is how I teach it. Okay? Now, let's look at example 1. What is the graph of y greater than 3x minus 1? Okay, here's what I suggest. Throw out the greater than sign for a moment. Just think about y equals 3x minus 1. Can you graph y equals 3x minus 1? Yeah. What form is this in? Okay. Yep. This is our y equals mx plus b, slope-intercept. So, we get to review this again. We talked about this earlier in the chapter. We get to review it again. Where do I put my first dot? At the y-intercept, and my y-intercept is -1 or 0, -1. I agree either way. So there's my first dot. Where do I go from that dot? Up 3 over 1 because my, what's the word there? Okay, I heard several things that are good. So my slope is 3. 3 as a fraction is 3 over 1. And so I heard rise over run. So from the dot you already put on your paper, you already put a dot at -1, yes? From that point, I'm going to count up 3, and then I'm going to go right 1. So I end up with a dot that is at 1, 2 if you want. You can make more dots, yes? I like to make more dots just because it helps me keep my line straight. So I like to continue and go up 3 over 1. I can go up 3 over 1 as much as I want. I can also reverse this and go down 3, left 1. Down 3, left 1. Okay, so that information all sounds familiar, yes? What do I have to ask myself as I connect my dots? Jacob?
I know it's something with like connected or not.
Okay. I use the phrase, is it a dashed or a solid line? So, dotted line, dashed line, whatever, however you want to phrase it. What kind of line do I draw here? Do I draw a normal solid line that connects my dots fully? Or do I draw more of a broken or dashed or dotted line? What do you think, Jacob?
Yeah.
And why is it dashed? Okay, it doesn't have that equal to part, yes? It's just a dashed line because it doesn't have that equal to part. So when I connect this, I don't know how you think about it. Do you think it is dashed, dotted, broken? But here's a dashed line. I picked dashed line because it was not equal to. It was only greater than. So I'm going to kind of off to the right here, set up a cheat sheet for you. A dashed line versus a solid line. Some of you don't need this. Some of you are saying, Mrs. Sargent, this is old news. We've done this before. I don't need this. And some of you are going to be thankful I'm doing this. So greater than sign, yes. When else would I use a dashed line? For a less than sign. When is it I'm going to use a solid line? When the equals to is on there. So less than or equal to or greater than or equal to. I'm just going to set up a little cheat sheet there, chart. If you don't need it, you don't have to write it. But if you want that little memory thing that when you're going through studying, you can see that and be like, oh yeah, here you go. Now, the other question is, where do I shade? When I teach this, I tend to use the vocabulary where you're going to shade above the line or below the line. Okay, anytime the line is already y equals, you'll never hear me say we're going to shade left or right. Okay, we're going to shade either above or below. What are your thoughts? Do I need to shade above or below here? Kendra? Okay, greater than, any type of greater than sign is going to tell me to shade above. And that's because it's greater than. I don't care what it's equal to or not. I care that it's greater than. Now, what does greater than, where is greater than on this particular graph? Where is above the line? Is above the line on this side or is above the line on this side? The one that kind of looks like the left side, yes? Now remember, it's not, I'm never going to officially declare it the left or the right, because above could be either. But you have to go with the angle of the line. And the way this line is angled, my above ends up over here on the left. If my line had been angled the other way, my shading above would have been on the right side. Okay, it all depends on how your line is angled. Now, you need some help here. I'm going to set up the other part of this chart. And the other part of this chart is, how do we know when to shade above versus shading below. So when are we going to shade above with what kind of signs? Greater than, whether it be greater than or, no, greater than or equal to. When do I shade below? Any type of less than. So regular less than or less than or equal to. You ready for this homework?
Yeah.
Well, I haven't taught the whole lesson yet, so give me a few minutes to hit a few other topics just to, Now, one thing I want to ask you, and this is trying to prepare you for the easy homework that they're calling me out that I'm going to have. So what if I ask you the question, is the ordered pair 2, 3 a solution of y greater than 3x minus 1. So I'll give you a moment to write that information down. I'll zoom in a little bit so you guys can maybe see that. But this is the next question we're going to talk about. So it's kind of a side note question here, but it's a really important question. So is the ordered pair 2, 3 a solution? What are your thoughts and why? Because there's more than one way we can get this answer. More than one legitimate way we can get this answer and decide whether or not 2, 3 is a solution to this inequality. Okay? What are you going to say, Kendra?
I did algebra run to find where the point was, and it wasn't in the shaded region. So.
Okay, now I wouldn't use the phrase rise of a run, but, okay, notice y greater than 3x minus 1, that's the graph we just graphed, yes? So if it's a solution, where should it fall in the graph? In the shaded area. If it's not a solution, it's going to fall in that non-shaded area. So if we look at 2, 3, where is 2, 3? Right 2 and up 3. Where does that look like it falls? That looks like it falls in the non-shaded area, which would mean that this is not a solution. Now, do you always have that graph in front of you to look at? No. What if Math Excel asks this exact question, but they don't provide you with a graph? You can make the graph, but what's easier than making a graph if you don't already have it? Plug it in. Because 2, 3, 2 is an X value, 3 is a Y value. Plug them in. 3 greater than 3 times 2 minus 1. Well, 3 times 2 is 6. 6 minus 1 is 5. Is 3 greater than 5? No. So 2 options, yes? If you have the graph, by all means, don't do that extra work. Just look at the graph. But if you don't have the graph, or if you're not 100% confident that your graph is correct, can you do this? Okay, questions on that one? Okay, so let's practice with example B. You've got all the information in front of you. We're ready to practice on B. What is the graph of y less than or equal to 3/4 x minus 1? So what do you know here? I'm going to think about the equation. Y equals 3/4 x minus 1. How do we graph that line? You guys are already doing it without me, aren't you? That's good. That means you feel confident how to do it. What can you tell me about this line? It has it has a slope of what? 3/4. And a y-intercept of -1. So first thing we're going to do is go down. Where's that first dot? Down 1. How do we do a slope of 3/4? Up 3/4. Is he putting it to music back there for us?
Yeah.
Okay, I went up 3/4. I can continue to go up 3/4 as many times as I want to or can. I can also reverse it and go down 3, left 4. And I know the graph is kind of, it's a little bit bigger graph than we had the other day, but it's poor quality, so. Okay, you've got 2 questions to ask yourself, in my opinion. What's the first question I need to ask myself?
Is it dashed or wait? Is it dashed line or a solid line?
Dashed or solid line? Solid line because? Okay, it has the equal to part. So this is a solid line. It's a solid line because equal to.
Yeah.
And what's the second question before I can call myself done with this problem? Okay, I like his vocabulary. Shading above or below? This time we are shading below because it is a less than. So shading below, I don't really have to discuss this one, do I? It's pretty obvious. Okay. I'm going to do a side thing. I'm not going to do example C because it's pretty much very similar to what we've done the last two, yes? However, I've got a couple of side examples I want to throw in. I'm throwing them in because if I recall correctly, you see them in Math Excel. So we'll just sketch graphs off to the left. You can use that graph. I have two of them to throw in, but you can use that graph for one of them if you want. But let me throw the what if example to you. What if I say y less than 3? Now, Carter? What? Now, 3 is not the slope because 3 is not attached to an x. So I have to veto that. Allie? It's not a vertical line. Horizontal line. Okay, so this is the equation y equals 3. Or if you want, it is y equals 0x plus 3. Now, I don't know what type of person you are. If you like that y equals 0x plus 3, okay, that means there's a y-intercept of 3, a slope of 0. The other thing, if you are an XY chart person, think of it. All my y's are what? 3. So I can say 0, 3, 1, 3, 2, 3. But one way or another, you have to determine and understand that this is a horizontal line at 3. I don't know how you want to remember it. I teach multiple different options there. But 1, 2, 3. So I have a point at 3. We can say 1, 3, 2, 3. You do the rest from there. My original problem was y less than 3. So what kind of line am I connecting with? A dashed line. And am I going to shade above or below? Below, because it is less than. Whoops. Okay. It's not that it's that much more difficult, but it is a special case, isn't it? And special cases tend to send us for a loop. So I just wanted to talk about this, a special case. I'll talk about the other special case here. Did you have a question or?
Why did the horizontal line
This line needs to go through any place where y equals 3. And y equals 3,
Right here.
any place like, so here if I go 0, 3, 1, 3, 2, 3, all the y values are where you cut through the y-axis at 3. Does that make sense? Now, if I just did y less than 3, can you take a guess what my next example is going to be like? No? Good guess, but no. How about if we do this with an x? Instead of saying y is greater than or less than some number, I'm going to say x is greater than or less than some number. My specific example here is x greater than or equal to 2. So we're going to do a graph here again. This time we're thinking about the line x equals 2. What are you thinking, Carter?
Vertical line on 2.
Okay. Based on the fact we just did the last one was horizontal, so this one is a vertical line cutting through where x equals 2. If you liked, I can't really talk slope and intercept here because there is no y-intercept and the slope is undefined. But I could talk xy chart. If you are an xy chart person, If it says x equals 2, what's that mean? All my x's are 2. 2, 0, 2, 1, 2, 2. So if we think about it like that, then I've got to point at 2, 0, 2, 1, 2, 2. Okay, so this is where, okay, so first of all, which type of line did you draw? A solid line, yes? No issues there. No one has to argue there. Now, my question is, do we shade above or below? And according to my sign, what's my sign say? It's greater than, so it says above. But the problem is we have a vertical line. This is the one time that this is the only time, instead of saying above or below, we now have to convert to left or right. So what is the equivalence of above? A larger number, which is found on the right. So even though we want to think above, we're going to shade to the right. So you see why I had to throw that example in. Okay, special cases. You need to remember when you see only an X or only a Y, that's either a vertical or horizontal line, depending on the case. Okay, ready for the other part? I know Clayton's back there saying, okay, let's go with the homework. I'm ready to go. I need to teach this part, though. Because as much as I'm saying this is Algebra 1 review, you didn't do this bottom part in Algebra 1. What's different about this bottom part? There's absolute value in here. What's that change about these graphs? What was it? It's not going to be linear? Is that what you said? Yeah, it's no longer a straight line. What are absolute value graphs? What shape are they? V's. Didn't you just deal with those in lesson 2.7? So these down here are going to be my absolute value V's. Now, the rest of this, the rules are still going to be the same. We're still going to ask, is it a solid or dashed line? And we're still going to ask, can we shade above or below? Now, one thing I would say, though, always start with y by itself. And it'll look a lot like what you've already grabbed. So instead of y minus 1, what do I want to do with this first one? Add the 1 over. So now, if I add the 1 over, it's y less than, you realize that 1 is not going in the absolute value. Y less than the absolute value of x plus 2, and then the plus 1 is outside. Kind of. Yeah, I mean, it does end up being a y-intercept, because what is that plus 1 going to do to my graph? Plus 1. The number at the end of the graph, or outside the absolute value, moves the graph where? Up or down. Since it's a plus 1, it's going to move it up 1. So there's a couple of different ways we can think about this. And if it helps, you can think y equals absolute value of x plus 2 plus 1. But that plus 1 is going to tell me to go up 1. What's that plus 2 going to tell me to do? Oh, you remember that list of things in lesson 2.6? It's in the absolute value. It's opposite direction of the sign. So that is going to be a left 2. So that means my V is going to go where? Left 2, up 1. What is that vertex then? That vertex is Negative 2, 1. I'm not saying you have to write all that stuff down, but these are the things you're either thinking left 2, up 1, or you're thinking vertex, negative 2, 1. So, I've got my vertex. How do I draw the V? Do you remember? Up 1 over 1? Is there any other slope, so to speak, here? No, because I have nothing in front of the X. So your V from that vertex goes up 1 over 1, up 1 over 1. On both sides, right? And then, to finish this off, same 2 questions. What's the first question? Solid or dashed V? I would say solid or dashed line, but it is still lines, I guess. What are we doing?
Dashed.
This is dashed. It is dashed because it is not equal to. Did you have a question, Carter?
Yeah. So, like, how far out should you space it?
How far out should you space what?
Your dashes?
There's no set way to space them. Make sure they're spaced enough that I don't have to squint and question, is that really dashed or is that a solid line? You know, I mean, don't make me squint and have to figure it out. But, okay, where am I shading? Below? What's below look like in this case?
Not in this, not
Outside the V, not in the V. If we'd been doing above, that would have ended up in the V. So in this case, that means, notice, what am I shading?
like a lot.
A lot. Everything that is outside of that V. And that is because we had to shade below. Now, my personal opinion is that graphing these is not any harder than anything we've already done. But it is a little different. Honestly, I would like to think, I don't know that I should admit this, I don't feel like I'm teaching you anything new today. It's more reviewing and pulling stuff you already know together.
Nothing's wrong with that.
So, okay, so maybe I am teaching you something new. Just depends on how much you remember it from the past, or which days you were there. Okay. Let's practice with the other one. Go through the process, make sure you got it. What's the first thing you're going to have to do? Add the 4 over. Make it so it is y equals, so to speak. So if I add the 4 over, y greater than or equal to absolute value of x plus 2 plus 4. Where am I moving this graph? 2 left, 4 up. I'm not getting involved in that fight. Okay, so if I go left 2, up 4, if you want, where does that put your vertex? -2, 4. How do I draw the sides of my V?
Just do it.
Up 1 over 1. Please make sure you have those dots. Don't make me question, does your V go through the right points? What kind of line are you connecting these with? Okay. This is a solid line because it is equal to. And where are we shading? It's greater than. So we're going to shade above. What's above look like in this case? In the V. Okay. On the back side, I just want to try and talk about the top two. And then I'm good. Okay? I'm not talking about problem 4 today, so we just need to talk about the top two. Which, the top two, we're basically just taking what we just did and reversing it. If you recall from our lesson 2.7 notes, we had the form y equals a times absolute value of x minus h plus k. That's the form you need to fill in. Okay, what kind of pieces of information can you tell me? Give me one thing.
The dash line says not to have it.
Okay, it's dashed,
Yeah.
so it's not going to be equal to. Okay. I say, let's go ahead and finish that whole topic off. That it's above, so it's greater than.
Yes.
Are we in agreement there?
Agreed.
The fact that it's shaded above means it's going to be greater than or greater than or equal to. Because it's a dash line, we are just going to use greater than. So I know y greater than. Okay, good. And it was Cyrus. My name was blanking for a moment. That's why I was just pointing at you, because the name was not there at that exact moment. Abby? Is what? Except the first number needs to be positive. But I believe it's
Oh, I think it's 3.
3 negative 2 is your vertex.
Yeah, wait. 1.
Hello? Yes. I can. Do you want them right now or when the bell rings? I'm just finishing something up, so. Okay, thanks. Bye. Okay, David, Officer Franklin wants you to stop by his office. Okay. Okay, guys, it was greater than. Vertex was 3 negative 2,
Yeah.
which those values go in for H and K. Or if you prefer, some of you may have just thought, oh, it goes right 3, down 2. So then if we fill that part in, absolute value of x minus h is 3, so it's x minus 3 plus k, what am I going to put?
Minus 2.
Minus 2. Okay, there's one part I haven't talked about.
You need to talk about
A. What's A basically represent? Slope. There's not great dots here. What's the slope doing? Up 1 over down. So y greater than absolute value of x minus 3 minus 2. Yes.
Would you consider it wrong?
I would not consider it wrong if you put 1 in front of it. Math Excel, I could see them counting it wrong if you put the 1 there. Okay. But you do that on like a quiz for me, no. There's no way I'm going to count that wrong. To me, it's equivalent. I'm always good with equivalent. Okay. Time-wise, we're about it. What's the difference on B that we have to consider?
It's upside down. B is up.
It's upside down, yes?
Yeah.
And so on that one, since it's upside down, we're going to have a slope of -1. And so in this case, my slope or my A value is going to be -1. Dang it. Okay. What's your vertex there?
I don't know.
I can't really like 4, 3, -4, 3.
Okay, guys, use the talking. Okay, so if you go left 4 up 3, vertex of -4, 3. And so -4, 3 are going to be my H and K values. Thank you. And then what kind of sign is this going to be? Where's my shading? Is it above or below? Above. So since my shading is above, it has to be greater than or equal to. What kind of line is this? Dash, so greater than. Y, greater than. Negative, absolute value. X, minus -4. So +4. And then +3. Okay. Lesson 2.8 is out there. Finish it for tomorrow. 2.7, if you didn't get that done, go back and finish that up. E-learning, if you didn't get that done, go back and finish that up. Other than that, have a good night.